Okay, hello everyone and welcome to Berlin Machine Learning Meetup. So we meet again online because of Corona, obviously. And we have three amazing speakers today and two super amazing talks and three super amazing moderators and organizers. So now I would hand over to Trent to introduce our first talk and first speaker.
All right, hi everyone. Thanks for joining us in the middle of the summer. So I'll jump straight to the first talk. The speaker is Sebastián Ramírez, and he's going to be talking about serving ML easily with FastAPI, and a very quick bio for him. He's the creator of FastAPI, Typer, and other open source tools. He's currently a developer at Explosion in Berlin, Germany. So with that, please take it away, Sebastián.
Thank you very much. Hello, everyone. Thank you for having me here. It's a pleasure, and thanks for assisting. So let's get straight to it. Let me share my screen now. So you should be seeing it now. Cool. So we're going to talk about serving machine learning easily with FastAPI. FastAPI is a Python framework for building APIs with JSON and HTTP. It provides high performance, it's easy to learn, and it's fast to code, and it's ready for production. So this is what we are going to talk about. First, who am I? I'm Sebastián Ramírez. I'm a developer at Explosion here in Berlin, Germany. I'm actually from Colombia, that's why the accent. You can find me on GitHub, LinkedIn, Twitter, all these things. I work for Explosion. Explosion are the creators of SPACY, the natural language processing package for doing things like machine learning over text. Also the creators of Prodigy, the package for doing data annotation with active learning for annotating datasets for machine learning. And think the functional programming deep learning library using Python type annotations as well. I created FastAPI, and Typer, we are going to talk about FastAPI. So about FastAPI a little bit, it has around 16,000 GitHub stars currently. It's been growing about 1,000 stars per month, so people have been liking it, fortunately. It's currently being used by Microsoft, Uber, Netflix, and a bunch of other organizations and entities. The performance is in the top rank for Python frameworks, so it's quite good. But now, why would it be useful for you machine learning people? This is what we are going to talk about. Why will it be interesting for machine learning? So FastAPI for machine learning people, I will going to assume you know machine learning. I won't teach you anything about machine learning. We are assuming that you know how to train your models, how to do your things. I'm going to assume that you know the basics of web API development. So you know what is JSON and you know what is HTTP, and that you send like HTTP requests with JSON to send some data or to receive some data. That's all I'm assuming that you will know. Now about FastAPI. FastAPI is based on standards. OpenAPI is an open standard for declaring how an API should look like. JSON schema is an API for declaring how the JSON payload or JSON data should look like. What is the shape that it should have? OAuth 2 is a bunch of standards to declare authentication and authorization things. This is what Twitter, Google, Facebook, GitHub, all these guys do. When you do authenticate with application X, authenticate with Facebook, or authenticate with GitHub, all that is running using OAuth 2. FastAPI is built using all these open standards and is built around them. So that allows it to integrate very easily with other tools. For example, FastAPI comes with Swagger UI, which is this additional front-end library that uses the OpenAPI to show automatic API documentation for your API. So you get this web user interface documenting your API for free. All this because it's based on open standards. So when you create a FastAPI application, you get an API based on standards for free. It's free. Cool. So FastAPI is based on Python type hints or type annotations. These are these things like, for example, here, this name is a string, or this price is a float. This is the standard syntax to declare the type of a variable. This is from modern Python, so Python 3.6 and above. And this is the standard way to declare that. We're going to see an example like this later, but the important thing is that this is the standard Python syntax, so it's not like a new syntax or something. This is the standard. And these type annotations are what provide auto-completion everywhere in your editor, and what provides the type checks and type error checks in your editor. So because types are the thing that provides auto-completion, you get auto-completion everywhere in your code when you use FastAPI, and you can make this little face of happiness. Cool. So FastAPI is easy and short. It's very small. The amount of code that you have to write to create an application, to create a FastAPI API, is very little. So this is a valid API. And what we do is we import from FastAPI, we import the FastAPI class. Then we create an instance of that class, an object app of this FastAPI class. And we declare here that we are going to receive an HTTP GET operation, or HTTP GET method, when someone requests the URL with the path /, so the root URL. And this is the function that is going to handle that. So this decorator, if you have ever used Flask, this is very similar to how Flask works. We are just also declaring what is the HTTP method that goes here. And then we are using this async function. We can use async, or we can use normal function definitions, but FastAPI is underneath an asynchronous framework, so we can do these things and use them when we know how to do them. If we don't know, we can just use normal functions. We will see an example of that later. In this example, we are just returning a dictionary, and FastAPI will take care of converting this to JSON for us. So we don't have to return a special class or something like that. We just return a dictionary, and it just works. And as you can see, there's very little code that you have to write to create an API. So the more FastAPI code you write, the less API code you end up writing, because FastAPI gets out of the way so that you can have like very little code to declare your API, and most of the code will end up being about your machine learning model and your business logic and your own application. Now, let's say that you have a machine learning model. In this case, let's see an example of with Spacy. So we import Spacy. We are going to load a natural language processing model with Spacy. We have the NLP object here, and we are going to use this NLP object to process some text. So we pass the text here. Apple buys UK startup of 1 billion. This text is going to be the input to the machine learning model. This is going to create this doc object, and then we are just going to iterate for each one of the detected entities in the entities of this doc. And we're just printing what is the entity text and the label. So here we're detecting that Apple is an organization, UK is a geopolitical entity, like a location or a location, a geographical location, something like that, and 1 billion is money. The point here is that this is a machine learning model that receives some input and generates some prediction. Here you could also have like some PyTorch model, TensorFlow model, whatever you need. Like the idea will be the same, that you have some input data and then you generate some prediction. And this is what we want to put in an API. So you have a machine learning model. Now what? Let's make it a web API. Why would you want to make it a web API? It could be to show it to your colleagues, to integrate it with other internal applications in your organization, or even to deploy it to production. If you need to deploy it to production yourself, then you could do this. The important thing is that the web API is going to be the main point of communication between your machine learning model and the external world. In most of the cases, that's how it ends up like living, just in some web API somewhere. So to do that, let's first go through the basics of a FastAPI application. So we import this FastAPI class, then we create the app with FastAPI, and now we are declaring this is the same thing that we were declaring before. Now we are not using async, we are using a normal function, a normal def. because FastAPI will take care of running it in a thread pool and making sure that it does the right thing underneath. But because we are going to do machine learning, and machine learning will consume a lot of CPU and stuff, then we want to do that always with these normal function definitions. And now we're going to declare some additional thing here. We're going to declare something to handle a URL like this. Let's say that our application leads at somedomain.com. We want to receive a request that goes to /items/ and this 5 is going to be a path parameter. So to do that, we say, we use the decorator app.get. This get also means that this is an HTTP GET operation or an HTTP GET method. Then we declare what is the path that we are going to receive here, and in curly braces we pass this path parameter. These curly braces are the same that we use for F strings or formatted strings, so this is easy to remember. And then this item ID, we're also going to pass it here as a parameter to the function that we create. So this item ID is the same item ID. And this item ID, we are saying that this is of type integer. Notice here that we are using this standard Python type annotations to say that this item ID is a variable that should be of type integer. So this 5 that we are sending in the URL is going to be in this variable. Also notice that this is a URL, so this is just like a long string, and it's going to be received as a string. But then FastAPI will take care of extracting this 5 and converting it to an integer. So in our code, we will actually receive an integer for this item ID. We won't receive like a string with the content 5. We will receive an actual integer. We are also declaring that we have this Q parameter here, which is of type string. And because this Q is not part of the path in the URL, then this Q is going to be, FastAPI will know that it has to read it from the query parameters. So these query parameters are the ones that are like key value pairs that go after the question mark in the URL. So FastAPI will read it from here. So this Q equals some query here in the URL. This some query is the text that will be contained in this Q parameter if it received like this specific URL. Now we are declaring that this Q is a string that by default is none. So we are declaring that it has a default value that is none. So this Q won't be required. Item ID is required because this is part of the path, but Q has a default value of none, so this will not be required. And then if with this code, if we run our application and we go to the same place where we have our application, somedomain.com /docs, then FastAPI will generate this interactive documentation interface for our API automatically. So we can see that we have the /items/ the item ID, the query parameter that we declared, and this item ID is also declared here. We have an item ID that is required. It's an integer. It has to be an integer and goes in the path. And we also have this Q, which is a query parameter, which should be a string. So from those standard Python type annotations, FastAPI is converting the data that we receive to make sure that, for example, this item ID is an actual integer, and is also generating this automatic documentation for us. So you write some basic code with type annotations, and good guy FastAPI goes ahead and makes a docs user interface for you and for your API. Now let's say that we want to have a basic FastAPI application with a body. We want to receive a body with data. So we do the same thing that we were doing before. We use the decorator app.post. This time is going to be a post, not a get HTTP operation. It will be a post HTTP operation or HTTP method, because we want to be able to receive a body. So we are going to receive something that goes at /article/, and then we declare in the parameters, we declare this article, which will be of type this article here with title case. So this article on the left side, this is the parameter that goes in the function, and this one is the type of that we are declaring. So this is a class that we create here. We're going to see that in a second. So this is the standard Python type annotation syntax to say that this article should be an instance of this class article. Now let's see how this class is created. So this class article inherits from this base model, and base model is here imported from Pydantic. FastAPI is based on Pydantic and Starlet. Those are the two building blocks. We're going to see a little bit about Starlet in the end. Pydantic is a library for doing data validation, documentation, serialization, and a bunch of things that you might want to check even if you don't use FastAPI. But FastAPI is built on top of Pydantic and uses it heavily for everything. So in this case, we are declaring that we have this class article that will have a field content that should be a string, and then it will also have some comments that should be a list of strings. This list comes from typing. Typing is a standard module in the Python standard library. So this is standard Python. And this is the standard way that you use to declare that something should be a list of strings. This comments by default is an empty list, so this won't be required. But content doesn't have any default, so content is going to be required. And because FastAPI will make sure that we receive an actual instance of this class, then we can use this instance inside of our code here to, for example, get the content of the article that we received. And now if we go to the documentation, then we're going to see that we have an HTTP post operation, or HTTP post method, that goes at slash article slash, which is what we declared. And now we have an example of what is the data shape that we have to send. So this is a JSON object, or the equivalent of a Python dictionary, that has the content that should be a string, and we have the comments that should be a JSON array, or the equivalent of a Python list of strings. So we already have documentation of what is the data that we are expecting to receive. But actually, if we go and click this try it out button here, then we can actually interact with our API live that we are running while we are developing, or when it's deployed. So, like, we can actually interact with the API directly from the documentation. So we can send a JSON body like this with some content. Apple buys UK startup for 1 billion. Some comments, nice, it was expected, something like that. And we are sending the data that we in the shape that we declared that we are going to receive. And here, when we click execute, we're going to receive the response that is generated live from our code. In this case, we're going to just receiving this message, reading Apple, blah, 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 which is the thing that we declared that in our code that we were going to receive. So with that, we already made a FastAPI application that receives a body. We made an API with a request body, and we can feel happy about it. And if you see, like, it was actually very simple code, and we already get a nice user interface for that. Cool. Now let's say that we want to have a body and a query parameter. We just do the same thing. We declare the parameter article of type article. This is the same thing that we were doing before with the class. And now we also declare this other parameter. In this case, we're going to call it big model, and this will be a Boolean, which is by default false. Because this parameter is of type Boolean, this is a simple type, Boolean, like Boolean, string, float, things like that. This is a very simple type, so FastAPI will know that it has to read it from the query parameter. It's not a complex type like this class, so it won't read it from the body, but from the query parameters. And it has a default value of false, so it won't be required. And we are saying that this should be a Boolean. Then FastAPI is going to take care of FastAPI will make sure that we actually receive a Boolean. We won't receive like a string saying with the content true. We will receive an actual Boolean, true or false. And if we go to the documentation, this is how we will use it. So we will go to slash article slash, we will send some body in the post request, and we will send this extra query parameter big model equals true if we want to use that. And the documentation will update and show the thing that we declared. We have this big model, which is a query parameter that should be a Boolean, and we can select what is the data that we want to send. Because the documentation knows that we declared that this should be a Boolean, then it can show us what are the only possible two options, true or false, because it already knows what are the things that we can send. So we can update the documentation and show us that. Cool. So we don't have to put everything in the body. We can put parameters in the query. We can use query parameters when it works. Now, let's actually do some FastAPI application with a machine learning model. So you don't have to do anything special. You don't have to use any special plugin or anything. You just do the normal intuitive thing. In this case, we're importing Spacey. We are loading a machine learning model here. Then we're creating the FastAPI application, the class to declare the body, like all the standard thing that we have been seeing. And now inside of the code, we are using our machine learning model. In this case, we are reading the content that we are receiving in the article. So this article is the same article here that comes as in the parameters of the function, which will be an instance of this class that we declared here. So this article is going to have a content that will be received in the JSON body. So we can read that article.content here and pass it through to the machine learning model. Then here we just get in the document, and then we are just extracting the entities that were detected and sending the entities back. So this is nothing too fancy. It's just very normal. But the thing is that we are just using these standard Python type annotations to get the data in the way that we declared that we were going to receive it. And if we go to the documentation, if we execute the same request that we were sending with that body, then we're going to see that indeed we received the response that we were expecting. We see the message and we see that it detected the entities, and we see the police and organization, UK is a geopolitical entity, 1 billion is money. And we can interact with that live. Now, let's say that we want to have a very complex data shape. We don't want to do machine learning for one article at a time. We want to receive many articles and do a single prediction for all of them. We just do the same thing. We use the standard Python type annotations. We are going to use this list, and we are going to say that we're not going to receive a single article. We are going to receive an articles, which will be a list of this article thing that we created. This is, again, the standard way that you do in Python to declare that articles should be a list of instances of this class article. And then we are iterating for each one of each article in this articles list. And then we are iterating for each comment in the comments of that article. And then we are doing machine learning on that specific comment. So if you see, we are actually having 2 nested for loops in here. And we are using all that. And the FastAPI will make sure that we receive the data in the shapes that we declared, and we can just like interact with that directly. And if we go to the documentation, we're going to see that it now reflects that this should be a list or a JSON array in terms of JSON of the same article thing that we declared. So using standard Python type annotations, we get all this documentation automatically, even for deeply nested data structures. But what happens if we send invalid data? So check this data that we are sending here. I'm going to let you check it and see if you can find any errors just by looking at it. We can see that this is actually valid JSON. This is a list or like a JSON array that is composed of JSON objects. So these are or the equivalent of Python dictionaries, and they have some stuff. Now, what happens if we send this? This actually has some invalid data inside. If we send it to the request, we're going to see an error like this. Let's see what is the error. So we have 2 errors. This is the first one. And it says that we have an error in the body, in the articles, and index 2. Let's see, where is index 2? Let's go back. So this is index 0. We have some content, which is some text, and we have comments, which is a list of strings, the thing that we declared. So this is fine. This is index 0. Now this is index 1. It has some content. Microsoft creates a new project template with FastAPI and Spacey, blah, blah, blah. It doesn't have comments, but we declared that comments had a default value of an empty list. So comments is not required. So this is actually valid data. This is a valid article. And now we are finally at index 2. This one has a text of invalid data won't be accepted, but this has text. This doesn't have a content. And we declared that we have a content that is required. So this one is invalid. And if we go forward to the error, we can see that in index 2, content is a field required. So we know exactly what is the error and exactly the location of that error. Now let's see the other error. We see that also in body blah, blah, in the index 3. So let's go back. This is index 0, this is index 1, like this whole thing is index 1. This whole thing is index 2, and now this whole thing is index 3. There's an error here. What is the error? The error is inside of comments at index 1. So let's go back. Inside of comments, this is index 0, which is a string, it's fine, and index 1 is this one. So we know that the error is exactly here. And we can see that this is a JSON object. This is not a string. And the error tells us that string type was expected. So we are not only getting data validated and an error saying that, hey, this data is invalid. We're also getting an error saying where exactly in the request was the problem, where was the error. And if we go back to the code, let's go back here in the code, all that data validation will have to be done here. And this is a lot of code that FastAPI is saving us. It's just, I don't know, like about 20, 50 lines of code, and we don't have to do any of that. So by the point that this code, that your code is executed, you can be sure that this code will be executed with actual valid data, with the data exactly in the shape that you declared. Otherwise, FastAPI will take care of not running it and sending an error validation, a validation error. So let's go forward. Here we have the error. Cool. So if you send invalid data, your application made with FastAPI will go and say no, and will get angry and won't run your code, will keep your code safe from running on invalid data. Now, because all this is based on these standard Python type annotations like this and like this and like this, then we can get autocompletion in the editor, even for deeply nested data structures. If you remember, this comment is each one of these strings that is in this list of strings that is inside of this comment, which is inside of each one of the articles in the list of articles that we are receiving. This is actually difficult to say. And we have 2 for loops to get to that data. And still, the editor is going to be able to know that this comment is of type string and will give you completion for that type, for a string, because we are using these standard Python type annotations. Being able to use these declarations, these standard type declarations, and getting this completion to work inside is very difficult if not using standard Python type declarations. Like if we were using some additional different type of class or something, this will be very difficult to get. And at the same time, we're also getting data validation for even deeply nested data structures. And at the same time, we're getting type checks. So because the editor is going to know that comment is a string, it's going to be able to detect that we cannot sum a string and an integer. We have to do something. We have to convert the integer to a string and something like that, but this is invalid. So it's going to give us like warnings and show us the errors even before we run the code. And we will be able to see the error exactly in the editor, exactly at the position where it is right while we type our code. All this, so auto-completion, type checks, data validation, data serialization, data documentation, all this because it's all based on standard Python types and standard Python type annotations. Cool. Now let's say that we want to add some metadata. Let's say that we have this big model query parameter that we had before, which is a Boolean. And now let's say that we want to add this description, use the big model. So this is what this big model query parameter will do. This will make us use the big model. We are not actually doing it here, but you get the point. This is how we get the query parameter. So we want to have this description in the user interface. To do that, we import from FastAPI, we import this query thing here. And then instead of setting the default value of big model to false, as we were doing here, we're using this query in here. And in this query, we can pass the description with the additional metadata. But now, because we are taking the place of what was the default value, because now we're using this strange query thing here, then query is going to receive as the first parameter is going to receive that default value. So the default value of big model is going to be false because that's the first thing that we are passing to query. And if we go to documentation, we can see that we have the big model, which is a Boolean. It should be a query parameter, and it has that default value, false, which is the same thing we had before. But now we also have the extra documentation, use the big model. So this is great. Cool. So we don't have to write documentation outside of the code. You don't have to keep maintaining a wiki or a shared document somewhere or keep fighting with the front-end team because the API changed or something, because they can check documentation live as you change it. Now let's say that we want to have a required query parameter. We just add the parameter and we add the type. So this is lang is going to be a string. This is going to be required because it's a simple type. This is not like a one of these strange classes or like a list or something. This is just a string. FastAPI will know that it has to read it from the query parameters. So then this lang, if we go to documentation, we are going to see it that is here, that is required, it's a string, and it should be in the query parameters. And if we don't send it, FastAPI will complain, and we are going to receive a validation error like this one. So this is the phase that FastAPI and your application built with FastAPI is going to make when you omit required data. Now, if we send valid data, if we send some string here, for example, this is how this will look like, lang n, this will be the query parameter. If we execute that, then we will receive the response as we were expecting it. Something to have in mind, one does not simply make all query parameters required. That is not common, and it will be strange and confusing for your clients and whoever is using your API, because it's just not common. But you can do it if you need to or if you have to. Cool. Now let's say that we want this lang string to have a minimum length of 2 and a maximum length of 2, because we just want to have like a language code, like N for English. So we can use the same query that we were using here before, and we can pass this additional validation stuff. We are saying that this should have a minimum length and a maximum length. But now, because we are using, we are setting a default value, we need to have another way to tell FastAPI that this is still a required query parameter. To do that, we can pass these 3 dots here. This is a valid Python symbol. This is called ellipsis. And this is the way that we use to tell FastAPI that this lang is still a required parameter. Because here, the first parameter, again, as here before, the first parameter takes the default value, but in this case, we are using these 3 dots to say this doesn't have a default value, this is still required. And if we go to the documentation, we can see that this lang is required still, and if we send invalid data, this has more than 2 characters, then it's going to complain, and we are going to receive a validation error. If we send valid data, if we send just the 2 characters, then it's going to work, and we're going to receive the data that we wanted. So if we send the invalid data, when we don't send valid data, this is the phase that your application is going to make. If you send valid data, your application is going to be happy and behave well. Well, it's going to behave well all the time, because that's what you want, but yeah. Now about performance. FastAPI is in the top rank for Python frameworks. Here, this is a benchmark run by Tech Empower, which is a third-party organization. And here, the green ones are Go or Golang, and the blue ones are Python. So this is not a fair comparison. Go is a compiled language. Python is an interpreted language. If Python was faster than Go, there will be something very wrong in Go. Like Go has to be faster because it's compiled. Nevertheless, FastAPI, among some other Python frameworks in here, is able to be faster than some of the Go frameworks. So that's quite nice. Which one of these is exactly the fastest is not necessarily that clear, that relevant. This has some random noise. You can see that they are kind of on the same ballpark. In fact, FastAPI, Ubicorn should be on top of FastAPI. Ubicorn is not a framework, it's the actual server that runs FastAPI. So Ubicorn should be here on top of everything. And FastAPI is built on top of Starlet. So that's why FastAPI is so fast. It's all because of Starlet. But the point is that you get on the ballpark of the best performance that you can have. And with FastAPI, you get all the data validation and documentation, all the stuff. And you can see that we are being able to handle 15,000 requests per second. So that's quite good. And it's over 9,000 requests. Now, some other features. FastAPI has a very powerful and simple dependency injection system that you can use to do things like handling database sessions or doing role authentications or like role checks or authorizations, things like that. There's also integrations with OAuth, so you can build things like authenticate with GitHub or stuff like that in your own application, and it's all going to be integrated with the interactive documentation interface. Because FastAPI is underneath is actually an async framework. There's support for WebSockets if you need to do WebSockets. You can handle files, send files, receive files. There's even background tasks that run in the same process for things like sending an email notification after sending the requests. After sending the response in a request or something like that, you can use background tasks for that. There's also easy GraphQL integration, and there's a bunch of other things like templates or like many other things that you will expect from a framework like this. Some other tools that you might want to check. Typer is for building command line interfaces, so the applications that you run in your terminal. This is more or less the same as FastAPI. It works more or less the same. You use Python type annotations, you get autocompletion in your code, but your users, your final users or your final clients will have shell completion with the application built with Typer, and it will work in Bash, Shell, Fish, C Shell, PowerShell, everywhere. Think is a functional deep learning framework that also uses these Python type annotations and is compatible with your favorite libraries like PyTorch, TensorFlow, etc. So these are things that you might want to check if you like these type annotations and type-based tools. That's what I have for you. Thank you very much. If you want to check the documentation, it's here, FastAPI. You can also check me on GitHub, LinkedIn, Twitter. And yeah, that's what I have for you. Now we can check some questions. Also, if you have some questions after this, you can go to the repository of FastAPI and ask them there if we don't get to cover them here. But yeah, thank you very much.
Thanks very much, Sebastián. Very informative talk indeed. Yeah, and sorry for the absence of any clapping or anything. I could do some clapping, but you know,
thank you.
Imagine the rest.
Yeah.
Yeah, there's a couple of questions there. I think some of them interesting. I mean, definitely interesting to a few people. Maybe I'll start just with the most popular one, which is someone saying that that they're already using, you know, Kubernetes and Docker for serving their machine learning models in production, and they're wondering, like, why would they switch to FastAPI, literally?
So Kubernetes and Docker is a containerization technology that it will be running some application inside. So you will have some Flask or some Django or something like that. FastAPI will be the equivalent of that Flask or that Django or something like that. Yeah.
Did it say Flask?
Okay,
cool.
Yeah, cool. Okay, then FastAPI will be the equivalent of Flask. Like, what is the difference with Flask? Is mainly the things that we just talked about: data validation, documentation, serialization, all the stuff. But yeah, like you will use Docker the same way. There's actually official Docker images for FastAPI, so you can just use that as well.
Yeah, I was so attracted by the Kubernetes, and no, but there's a similar thing. Actually, someone asked, is there, like, can you briefly maybe compare, because they're using Django REST framework.
Yeah,
I guess it's one of the other ones.
Yeah, so like one of the things to have in mind is that I didn't add here just to not cover more time, but when not to use FastAPI. If you have already like a Django REST framework application that is working very stable, you don't need to add any more new features, and it's just working perfectly, like it's probably not a good idea to just switch to FastAPI. You might want to do it if you want to add like new layers of API code, and you want to have like simpler code, and you want to have like the benefits of FastAPI. But like what many people can do is also like add just a layer and keep the previous code base before. I have done that before, for example, with Flask and having a Flask API and then add a layer of FastAPI on top for all the new stuff. At the same time, there's a bunch of teams that have been migrating from other frameworks like Django REST framework and others to FastAPI, and they have been like happy about it. But still, like it's not necessarily the best idea to just go crazy and migrate everything to FastAPI.
Mm-hmm. Okay, great. There was another question about Flask, namely one about Flask's feature called blueprints, which I suppose is like a way of having Flask apps share Flask code so that you can use like a module within your Flask app.
Yeah.
Is there something like that for FastAPI, or is there a need for that?
Yeah, so Flask blueprints, the equivalent to FastAPI will be an API router. This actually, if you search Flask blueprints in FastAPI, you will get directly to the docs for that. And it's just like a way to split the code in different files and being able to merge all those different sections of the API in a single like big application, to be able to have like very big applications with multiple files.
Mm-hmm. All right, I think that's plenty of an answer. Now there's been a couple of questions around, async, normal functions, and concurrency and stuff like that.
Yeah.
Some questions around that. Someone was wondering about, when they are serving their ML model, what happens, when there's multiple requests coming in at the same time? Are they going to run through like copies of their machine learning models? Like, how does the concurrency stuff work?
Yeah. So the thing is, let's try the short version. If you want to check like all the details of this async and normal function definitions and all that, there's a whole section in the docs trying to explain that in very simple terms. If you are not sure what to use, and if your libraries don't support directly async and await, then you should just use normal function definitions. FastAPI will take care of doing like the right thing underneath, which is running the requests through a thread pool so that each request doesn't block the main event loop. But then if you are serving a machine learning model that could be consuming a lot of resources, just generating a single prediction, then that machine learning model will still, for a single request, could consume a lot of, could consume the whole core, the whole CPU in that process. In that case, you might want to run several processes. So you could use Unicorn to serve Ubicorn. You can check it in the docs, but the thing is that you can run several processes that all run asynchronously, but in parallel, all of them. So you can be predicting generating several predictions at the same time for different requests. And if you use the official Docker image, it just does all that for you by default. So yeah, that will be like the way to do that.
Okay, great. I mean, there's another question, but I think that's also answered by what you said, is that you're recommending using normal functions rather than async functions when serving ML models.
Yeah, that's correct.
All right. I think I saw a new one popping up. Since we have some more time, someone was wondering about sensitive data and if there is something around, encrypting and decrypting data before it enters, as it's being transported, I guess, or when we call the FastAPI.
Yeah, so for example, in terms of using other libraries to encrypt data, you can use any library you want. FastAPI doesn't have like any hard requirement on any type of database or any type of encryption or anything like that. You can use any library that you want that works in Python, and you can just use it directly. If you want to have encryption between the API and the client or the front end, you should probably use HTTPS. And that's just the case, all of the time. If you have something that is public, it should be through HTTPS. That's normally not handled by the framework itself. It's normally handled by a TLS termination proxy like Traffic, or like you could also use like Nginx. And then you could use something like Let's Encrypt to generate the certificates. It's actually, there's a small guide in the documentation about how to do HTTPS for these types of use cases.
All right, great. Just scrolling through the list of questions to see. There's a couple of new ones at the bottom.
Also, if there's any other questions that we don't get like to cover here, or if someone has a question like afterwards, they can also like ask them in GitHub. Like, of course, we can keep checking if there are more here, but like if later you have more questions, they can like.
Maybe we'll just ask a last one, okay? Someone was asking about latency. So, is there a way to indicate that their function is going to be sensitive to latency? I suppose.
Yeah, I guess it will probably have to do with profiling the application and checking like what is taking most of the time in the execution. FastAPI is based on the new standard for building web applications in Python, which is called ASGI. The previous one was WSGI with WSGI, WSGI, which is what Flask and Django are based on. FastAPI is based on ASGI. Which is this new standard. Because it's a standard, there's a lot of libraries and tools and middlewares that you can also plug in directly, for example, to do profiling of what is consuming resources in the backend and stuff like that.
Right. Yeah, someone also applauded your effort of writing very nice documentation. They say it's been helping them a lot. I can agree with that. Okay, so I think we're done. Thanks again very much, and
thank you very much. Thank you for having me here.
Over to Trent with the next talk. Bye.
Great. Yeah, thanks again, Sebastian. A really great talk, and I've actually played with FastAPI as well, and I liked it a lot. So thanks for the very informative talk. Next up, we have two speakers that are going to speak together, and it's my pleasure to introduce Katja and Sean, both from datastories.com. And a bit of a bio, they are the CEO and CTO of DataStories International, and DataStories develops software and solutions to bring ML closer to business people. They'll share feedback, practical requirements, and concerns of business users about AI, and discuss trade-offs for explainability in the current ML ecosystem and focusing on automatic ML. And yes, it's really my pleasure to have them on. I've collaborated a lot with Katja over many years in various AI things, so it's really great to have you on. So please take it away, guys.
Thank you, Trent, and everyone. Happy summer. Let me share my screen. So I am Katja, very nice to meet you. You don't see the screen. And this is me and Sean, who will talk today about explainability in machine learning. So a little bit about us. So for my side, I'm Katja. I'm CEO and founder of DataStories. I'm in the field of data science at least since the year of 2003 professionally. I was involved, I think my impact here, or maybe I have a special perspective because since then I have been involved in very practical applications of data science and machine learning. Just as a part of DataStories, I participated in more than 60 different projects. They are all industrial strength machine learning applications. I do have a doctorate in data-driven modeling, doctorate in industrial mathematics, and nerd alert-wise, I also have a Master of Science in complex systems. So I guess I was reading the books of Vladimir Vapnik and Alexei Chervonenkis just for entertainment at night in Russian. They are the founders of computational learning theory. That would be me. Sean, please introduce yourself.
So I'm Sean Steven. I'm also at DataStories since the beginning, since 2011. So I also did many projects in computer science and data science. My background at university is mostly computer science, but since 2009, I also have been working on many data science projects and modeling of complex systems. At my time at the university as a PhD candidate, I did a lot of work in modeling infectious diseases and building machine learning models also to predict those things. And secondary, of course, now at Data Stories, I'm the CTO, so I'm responsible for maintaining the products. And yeah, if you have any technical questions about our backend, then you can ask them to me.
Good. Thank you. So Data Stories, we don't have a slide about it, but we are machine learning advanced analytics software vendors. And I think the mission of both Sean and me and our entire team is to make machine learning usable and enjoyable to use for business people who are not necessarily data scientists or data engineers or are machine learning pros. They could be material scientists, biologists, process operators, engineers, all kinds of scientists, but not necessarily learning pros. And so the question is always, how do we make sure that they can use and trust the results of ML and AI? We would like to start with the first scare. So before Corona happened, the most important strategic technology trend of 2020 was, of course, democratization. So let's democratize technology, and all the companies, front runners, have been investing massively into democratization of technology. So two statements here coming from Gartner. The one is a scare. So by 2025, which is in a very few years from now, people like us, like data scientists, will be automated out. And so the scarcity of smart data scientists will no longer hinder the adoption of digitalization and machine learning in large organizations. That's the first statement to take. Well, I'm a data scientist myself, so I'm not bashing our community, but I would like to share that, in my humble opinion, the positions who will not be automated out will be data scientists and machine learning practitioners who actually also have the soft skills and are having a role of a translator. They're translating data science to business science and back, as well as people who are algorithm tinkerers, which I think is a representative population of this community. So, and then the second part is that very soon, again, among the large enterprises, the business, this would be then our focus, will be using several tools, which are low code development tools for both IT application development and data science, in this case, development. So citizen data scientists are people who are using machine learning in their daily work, not necessarily being absolute experts in data science. So this is a scary graph, just to set the stage. And I really would like it to be, so it will be hands-on, but maybe a slightly higher level talk than what Sebastián showed you. If we look at the middle part here of the main actions that we need to do to make sure that machine learning is solving critical business and life challenges. We start with problem definition and then go through the whole bowl of data collection, engineering the right features, building machine learning models, evaluating them, and then applying them. So today we can look at this process as actually a dialogue between a human who is a domain expert, we would call them through the talk, who knows the context of and the application, and an automated machine learning tool. So for the human part, the humans need to focus on defining the problem, collecting the data, and then ultimately applying, potentially helping with feature engineering, but these days it can happen automatically, and then obviously applying the machine learning models so that they bring business value. The AutoML part, automated machine learning, which has become pervasive now, is focused on feature engineering, training the models, evaluating the models, and helping with applying and industrializing the machine learning results. So this is why they call it now augmented analytics. We augment human intelligence by powerful computational tools. So the problem is that this last part, which has to do with applying machine learning models in real business for solving real problems, is going to fail if the domain experts do not trust the models. Obviously, I'm likely preaching to the choir here, but if we cannot convince the users, the end users who are there in a field or in a production environment, that our models are trustable, they will never be applied and it will never fly. Innovation will not fly. Coming back to what, so the focus of today is passing on the plea from the users who are domain experts to us on making ML explainable, on helping humans understand why our tools and algorithms have developed solutions as they are and how to use them. So the Wikipedia definition is explainable AI just refers to methods and techniques of AI, which actually make the solution such that the results of the solution can be understood by humans, nothing else. And in our definition, so we data stories who are really focused each day, every day on making it practical and usable and explainable, we would say that an ML model becomes a lot more explainable if it is used by a domain expert, himself or herself, so that the people can validate or disprove the hypothesis, disprove their behavior, the model behavior. And it's best if it is done without our involvement. You ship the model, you serve the model, people look at it and say, aha, okay, I know why. Not necessarily how exactly the model was created, but why it is like this and why can I trust the predictions. We'll give a few examples here. So now we would like to give this short story from our perspective. And we, so Sean and I are practicing very, very practical industrial scale machine learning and data science. So what we focus on and all our applications are in industrial, in industry. And what we would like to claim is that machine learning actually there does facilitate daily, each day, every day, the holistic end-to-end business understanding of any business that makes things. If we talk about businesses that make things, there are different facets of the value chain, and we go from raw material, so to manufacturing the stuff. So we need to buy things, we need to turn it into products, we need to distribute the products, we need to make sure that these are the products that our consumers and customers like to buy and will keep buying. And then we want to recycle them efficiently. So every single message here is an example of a target that we as machine learning practitioners would use as our target to optimize or model or predict. Few things, if interesting, just shoot questions about it. So maybe most frequent applications from our perspective of machine learning are in the area of manufacturability. So like example would be, why did I put these examples? Just to for you that every statement here requires explainable model. It's not going to be I will not, so if I'm looking for new opportunities to maximize yield of my production line, or I want to minimize quality deviations of the stuff that I am making in my production line, I will not be able to just buy a black box model where I do not know what are the inputs and how exactly was it constructed and how it is being calculated to predict me the outputs. The same holds for reducing losses during changeovers. I'm making things and then I change my line. I'm making, let's say, 35 different types of yogurts on my production line. I'm now going to food because it's dinner time. How do I make sure that I do not lose product while I'm changing my line from one SKU to another? Quality deviations among batches. So all of these statements, which are real business problems, they do require explainability. People need to, before they go and deploy the solutions in their real processes, they need to trust the solutions. So it cannot just be a black box, plug it in, so put your inputs here and do whatever the model is spitting out to you. Right, so this is the setup. Reducing giveaway, shortening new product introduction time. We need to create, and here I added consumer insights, a very popular application area. I am, again, let's say a food company, I need to launch a new non-dairy yogurt product, and I'm focusing on young female consumers between 18 and 28 years old who are health conscious. What would this persona want from me? What can I mix together? How can I produce it to maximize the uptake? Other examples of applications which do require explainability, so people will not accept a black box, again, based on our experience, would be in customer intelligence. Why do our customers leave us? Not predicting who will leave us, but really understanding why is it happening. Customer lifetime value prediction. People analytics, why do employees leave my company? Or how can I increase employee effectiveness? What exactly do I need to change to push these targets in the direction that I need? On manufacturing, we mentioned yield optimization, waste reduction, preventive maintenance. How do we go from time-based maintenance of my expensive machinery to condition-based maintenance? Energy management, how do we lower the energy, which is not just electricity, but also gas, water? Product service innovation and financial intelligence. So all of these applications are real applications, and they do need explainability. People will not take a black box model. So from our perspective, if we talk about machine learning in industrial applications, the easiest way to explain it to the technical people is really connected to the system identification problem in engineering. So I have my system, this is my process, or actually a product, and it has certain behavior, and these are the outputs or the targets in our machine learning terms. So I will have multiple targets. I call them performance targets. I want to optimize them. I want to keep them at certain desired ranges. I want a super high quality product at the lowest possible price, and let's say the longer customer lifetime value or the highest loyalty. So this system is usually, so there are some inputs that come into the system. If I'm making a certain product, which needs to be high quality and at the lowest cost, I do measure multiple inputs. There could be many of them, there could be hundreds or even thousands of them. At a normal production process of making any complex food product, we will be talking about 300 to 500 to 4,000 different measurements. And then the system is also potentially influenced by some unmeasured parameters like ambient temperature or humidity, or whether we are 20 minutes away from our dinner or this is a Christmas time. So what we want to do, we build machine learning models to actually build copies or proxies for our outputs, to replace our outputs with models. And what is the issue here is that we want these models to be explainable. So what are the most frequent questions that practitioners are asking about then their data and their process? Is they want to know how all these inputs we are measuring and outputs are connected to each other. They want to know what impacts, which of the inputs of the bazillion of things that we are measuring are impacting the targets, the outputs, and how can we be sure about it? Then ultimately, in I think 98% of our applications, the focus is prediction and optimization. What can we change on the input side to achieve the targets that we really want? And the last one is, what are exceptions to the rules? What are the anomalies in my process or my system behavior that I need to be aware of? How do I make them transparent? And ultimately, because we are going to talk about really prediction and optimization problem, which is very often the case. In case of, let's say, market predictions, if there are people who are predicting the price of ethylene for the future to make budgets for their sourcing, there, of course, they cannot really reverse engineer and optimize it. It will be what it is. In most of the other cases for industrial applications, we see that the target is really to figure out what can we do to achieve the outputs, the performance targets exactly the way we want it. So we're solving a constraint optimization problem. I'm optimizing all my outputs subject to some system constraints. And why do we do machine learning? Because we want to replace it by actually optimizing the models, which would be then explicit functions that our algorithms create subject to system constraints. And what is the ultimate challenge? Why are we all in this business? Because the system is immensely complex. And there are so many things that may or may not influence our outputs. The causality is non-transparent. There are so many signals that we need to make sure that the models we create are satisfying certain desired criteria. I would like to give you a use case. It is again about food. I thought it's the easiest to transfer. So Sean, please interrupt me if I forget to mention something. Do you have any comments on this?
Not yet. That's very nice.
All right. Good. So then I would like to give you a real example and then also highlight the urgent need of explainability, but also the price we are paying for explainable models. So industrial potato baking. It does sound very mundane, but I wanted to mention, so we are a Belgian company, and Belgium is the world leader in exporting potato frozen foods. So it's apparently Belgium alone is producing, a country with a little bit more than 11 million people, is processing more than 5 million tons of potatoes per year, with a net, I think, capital of 1.75 billion euros. So it's a very big business. For this demonstration, I would like to use a simple data set. It's industrial potato pre-baking use case. I have batch data, which comes from real process. The data has been kindly provided by the S4 software company and comes from their web form module, Netcare. So they deliver software that optimizes food quality during the production. I have 5 feedstock parameters. So I'm making potatoes. I'm buying the potatoes. I'm peeling and cleaning the potatoes. I'm measuring some properties about it. So I need to know the variety, the race of a potato that I'm buying, the origin, the country it is coming from, what is the level of discoloration, what is the color, what is the sugar content, how many days since harvest. And I'm buying it obviously in tons and tons. Then I also measure the processing variables, the process parameters, and they are different types of temperatures. How long do we keep the potatoes in fat? Apparently only in Belgium, often they bake potatoes in fat, not in oil. Humidity, fat content, the scraper speed, percentage anti-foam agents in water, etc. And we have 2 targets to optimize. It's color after oven and waste after oven. So I am buying 10 tons of new potatoes that come from the Netherlands and let's say are of this variety. My goal is to know for this load of feedstock, what should be my process parameters such that I will get at the end of the batch nice and golden brown potatoes with a minimal waste after oven. So this is a multi-target optimization problem. I need to optimize 2 targets, color after oven and waste. But the color is not just minimize or minimize, it needs to be 3. And it changes between 1 and 6, 1 being super light and 6 being very black. Oh, not nice. How do we solve this problem? I would like now to shift my screen. Let me see. Please let me know if you lose something. This is a brief demo of data stories. The focus here is on explainability. So I'm not going to show the tool, but the point is I upload maybe for your information, this is how the data looks like. It's a small data set. Every row is a batch. I have my batches, I have my process parameters. Blue is related to raw materials, purple, lavender in this case, is related to process parameters. And here I have like color after oven in text, color after oven numeric, and waste after oven. So I upload this data. And the way, so I would like now to share with you how our users and people who are making things want to have the solutions. So we have our proposal for explainability, and this is what we are currently doing, and we would like to share where we're going to. So I uploaded the data. I selected 2 targets as my KPIs, so I'm optimizing them. And first, we need to build predictive models. The very first thing I need to do is to know what are my knobs that I can turn to simultaneously impact 2 targets. So on the columns are my KPIs, so my targets, color after oven and waste after oven. And rows in this table are the drivers that we have identified. So these are the results of machine learning. So there is a story associated with it. The point is, out of 17 things, we have identified 5 things which together impact my process targets. And there is 4 drivers that impact color after oven. So we see that sugar content is apparently a driver which drives both outputs. Percentage of anti-foam agent in water also drives both. Then days since harvest is completely not important for the color of my potatoes, but is important for the waste. And the other 2 things are for the color. What I then would like to do, and this is many machine learning practitioners believe it's fun, so that's why we thought we would show it to you. So this is how we believe we can facilitate interpretability and explainability of models which are black box, gray box to black box. So first of all, we did our variable selection and we identified the minimum number of drivers which impact, in this case, 2 targets. You see here graphs. On the vertical axis, I have my color. So this is my first KPI. I have my color after oven. On the horizontal axis, I see how it will change if I change any of the inputs. So these are my inputs. I can do it in real time. What we're now plotting here are the multidimensional projections. So I say if I change time in tank, how long do I keep my potatoes? While all the other inputs are set to their respective values, this is how it will change. Since days since harvest will not impact the color after oven, but it will impact the waste after oven. So for the waste after oven, the amount of waste apparently is impacted by only the top 3 things. So first proposal for explainability is to make sure that the models are smooth. They are nice to look at because people, not us, not machine learning people, but people there on this production line will be looking at the models and they want to understand how exactly, by how much exactly things will change, outputs will change if we change inputs, if we introduce variability. The one thing, so like I can now maximize waste after oven. So the worst case scenario, the best case scenario, I can globally optimize my targets simultaneously. But what is more important would be to give my end users, they're not data scientists, not Python programmers, or they could be, of course, is to give them a possibility to do this optimization of multiple targets at the same time in an easy to use and visual tool. So I say color after oven is my KPI, very important. What I would like to do, if you remember, I wanted to be as close as possible to 3. So I would like to say I wanted to be between 2.7 and 3.4. And it's a mandatory condition. I really want my potatoes to be of gold brown color and not like too light and too dark. I also want waste after oven is a very important parameter. What I want to do is I want to minimize it absolutely. And then I ultimately here below, I have my inputs. So average temperature after oven, days since harvest, percentage anti-foam agent. I would like to also save, like every time I put my potatoes in a tank, I need to put anti-foam agent. I would like to actually cut costs and maybe have some desirabilities on how much agent will I put in every batch. For the rest, time and tank, I can also put constraints on it because I wanted to be as fast as possible. The shorter are my batches, the more production can I do, the higher is the yield, and the better my business would be doing. And I click start. So what happens now is we built machine learning models before that. So I showed you the results of the models. We're now running the multi-target optimization, which will try to find us an optimal solution that hits all desired targets, as well as satisfies the constraints that I put on my inputs. So here at the end, you see in real time, okay, sorry, I should have scrolled, how the sliders were moving. And now I can see that here is the solution. So I found the solution. So the red point is the current proposed solution. I say that my color will be 3, and the waste will be minimum. If my potatoes are of lowest sugar content, I can use so much percentage of anti-foam agent, etc., and keep my potatoes there in tank for so long. The other types of questions in reality that our end users could ask, well, I cannot control the sugar content, I buy what I buy. So if I have the machine learning model, and if it is industrializable and deployed and always at my hands, what I can do, I can then set the sugar content. So while I measured it, I know that we currently bought a batch of a certain sugar content. I run my optimization, and then I will exactly solve the real business problem. Given this load of raw materials, what should I change, by how much exactly, to achieve the targets that I want? If I like it, I can then go. So here now we're running the optimization problem. I can change here and see whether there will be any additional improvements. So here, solution found, bam, this is it. I can now go and deploy it, so change my process according to this recommendation. And also export the models in a language that I want, if I then want to go and deploy them further. So this is an example of what we believe. I'm going to go back to my what in our experience is explainable, and the visuals we have done after multiple iterations with our existing users and prospects. And the current approach, which is very similar, if any of you have ever worked with all statistical analysis tools like JAMP, we could use these sensitivity profilers when we build linear models, and they're all very smooth. I can change inputs and see how outputs will change. So this is our proposal for machine learning. What is then the summary of the outcomes here? Just to restate it, first of all, and again, this is not formulated in my words because I think it's cool, but in the words of the end users. First, we get the insights on the drivers. So we're not looking at everything we're measuring, but we're only looking at the drivers, that 5 things that impact our 2 outputs. We get predictability because for any combination of then those inputs, we can see what the outputs would be in real time. We don't need to wait and really bake things. We get optimization. For any feedstock quality, we can get recommendations of what should be our process parameters. And ultimately, we get additional business value with additional insight. So this is AutoML, Auto Insight. Or, for example, we can inform our sourcing department that we need to buy potatoes, so the next batches, maybe we should offer better prices, or inform our suppliers in a particular sugar content for our raw materials. So there is an additional business insight generated here. This is for the use case. What is then going back into the algorithms? This is a very simple graph. I have taken it from the same report of partner that I quoted earlier. So just 5 myths about explainable AI. We obviously, if we plot all different algorithms on 2 axes here, explainability versus accuracy, and we can plot them, so this is approximately a line, so there is a trade-off. The more explainability usually comes at the price of lower accuracy. The more we go into the black box up there, so deep neural nets would be here up there, very accurate, but hard to explain. So this is the continuum we are operating in. Starting with decision rules, very easy or very simple, explicit formula models. Logistic regressions, decision trees are here, closer to the edge. So we want to balance really the one important statement that we're making here is this explainability accuracy trade-off is actually depending on the application. And what we need to do, and this is our invitation to all of you, is to inform our stakeholders, so people who use machine learning for their problems, are aware of those trade-offs. And so let's make sure that the stakeholders appreciate the necessity of the trade-offs in accuracy and explainability. What would you like to do? You want it very explainable, simple, where you know the drivers, where you can play with very smooth machine learning models and understand why and how your changes in the inputs impact changes in the outputs. Or you want to have a very high accuracy, and then you need to go to black box models. Again, there is plenty of applications which don't care about explainability if accuracy is of the issue. Like the forecasting, of course, there is a lot of details there, is one of those things where you really care the most about accuracy of predictions, not necessarily extrapolation or reverse engineering. So this is where we need to be, and every single business user, super smart people with many PhDs there and practitioners are telling the same story. We thought machine learning is now the thing. Okay, we thought we will go and learn machine learning, but we looked at the models and know without spending many years on studying the true differences and pros and cons of different algorithms, it will be impossible. So we believe that we as machine learning practitioners can facilitate the process of helping people adopt our algorithms and invest into explainability. And one last, so here's what I wanted to mention is, if you have a process, and let's say it's a very, very complex system and a complex process, and we need to have a high accuracy. So we built a black box model, which is probably an ensemble-based model from multiple complex, let's say, deep neural nets. One of the solutions and the shortcuts there that we're suggesting is to come up with proxy models, which are simple and explainable. And we know we want to be able to build these global machine learning models everywhere in the search space. But we can still provide the end user, with proxies on subspaces in the search space, the models which they can look at and interact with. What I wanted to share with you, it's a really old stuff. I went back, and so this is, I think, a copy from my doctorate. We published about it 17 and 13 years ago. What were, at the time, it was called empirical or data-driven modeling as an antonym or a complement to fundamental models in industrial applications. And we were the 5 properties of models. This is just an invitation to the modern machine learning community to look at it and see where over the last 17 years we could check the check boxes. What is a good data-driven model that we can then apply in an industrial setting? It needs to be capable for online reliable prediction of system outputs and also give the trustability of this prediction. So we always need to have a confidence in the prediction. Without the confidence, it will not be applicable in real life. They need to be interpretable and ideally have a possibility to integrate information from like the fundamental models, the principles, or the a priori knowledge that people have about their processes. Let's say I'm building this curve, but I know this is a monotonic curve. How can we integrate it? It needs to have low development and maintenance cost. I guess here we are definitely here. We have built many AutoML systems, which with just a few settings and hyperparameter optimization can absolutely lower the cost of development and also of maintenance. But the models also need to be robust with respect to variability in the process inputs. So that's why they need to be also smooth. And they need to be adaptable. So this is the last requirement that we had. Nothing changed. We still want to have it. The models need to adapt to the novelties in the data and tune or alarm you, the end user, when things have changed, the new regimes have been achieved. Sean, do you want to add something?
No, this is complete, I think.
Okay. So I guess this comes more into, I mentioned the robustness with respect to variability and one, I don't want to go into a deep philosophical discussion, but shoot us with your questions on what is smoothness is one of the features of machine learning models. Actually, if we look at them as as a multi-dimensional surfaces or ensembles of surfaces in a high-dimensional space. We believe that if the model is smooth, it will be more pleasurable to look at. It will also be less dependent on the variability in process inputs, and then it will be easier to adopt. So this is an example of an algorithm. So the models before were built with one hybrid machine learning algorithm called Rainstorm. These are the models built with sklearn. These are just very simple random forests, but there is 100 models in it, built on 500 points. It's a simple linear model with 4 inputs, x1, x2, x3, x4. And the model has quite good accuracy, high R-squared, and yet I see visually that it is jiggity because there may not be enough points to cover this 4-dimensional space. This model will obviously be less preferred for Y than a straight statistical model, which is an equation with confidence intervals. Sean, I will let you take over here and talk more about smoothness and maybe give additional examples.
Yes, I think it's also important to mention that most AutoML tools, they don't optimize actually exactly for smoothness or things like that. Like when you run an AutoML tool, always what you get is the model that scores best in like accuracy. But when you're talking about explainability, it's often way more important. For a user, it doesn't matter if it's 98 or 97, if they really want to just understand how the system is behaving and so on. And in this case, sometimes there's an argument to be made to use simpler models, but that just give a bit more insight. And I think Katja, you can go to the next slide. Yes. So this is just an example. Just I think on the right is just on the left is a simple data set. Well, simple is a data set, just 6,000 points. It's like the MATLAB function that you often see. On the right is just the same thing, but then predicted by a random forest using sklearn with a grid search to find the optimal parameters. And of course, accuracy-wise, it's very good. It works perfectly. But for example, when we want to do the same thing like the optimization that Katja showed you, a function like this is really not fun to optimize because it has very many straight parts, and then there are cliffs and so on. So it's way more difficult to actually make it, to explain it and to use it for things like optimization. And I think, of course, you can tweak those algorithms to have more smoothness and to optimize for that. But in our experience, most of the people don't look at it and they just purely look at accuracy. And I think this is a good case to be made to not only look at it.
And we would like to mention, like, what is explainable? If your end user is not sure whether it is explainable or not, it is likely not explainable, right? So if you have any doubts, it was not it. And the question is, how can we adjust our algorithms or provide additional proxies to the users to make the insights easy to digest and adopt and then go and deploy? This is a goal that I hope many of you will share with us. Sean, you want to go here? That's our proposed explainability solutions.
You can go. These are your words.
Well, so what we have tried and tested and showed and improved are the solutions that improve explainability for black box models. So I'm not talking about symbolic regression models or simpler or rules, because clearly there will be a very big limit to what simple rules or decision trees can achieve. If we talk about black box models, then simple solutions would be to make sure that we serve models which have minimum number of inputs, and they are consistently rediscoverable as drivers of the outputs. We don't want the real practitioners in the field will always prefer a 5-variable model to the 25-variable model. So we need to have variable selection is a must-have, in my humble opinion, in an algorithm. And again, if we build an AutoML system, we might as well implement it either as a part of the algorithm or as a part of our workflow. We need to have interactive input-output profilers. People love it and users love it to change the inputs and see how, what would be the corresponding changes in the outputs, because then they can quantify the business value. We also want to augment, as I mentioned, black box models with smoother and more interpretable proxy models. One of the comments we get is, okay, guys, now we actually see that the models are accurate across the search space. We usually build linear models, and for some processing conditions, we can build high accuracy, but models do not extrapolate at all to other areas because simply they are linear. And but this trick of shipping our accurate black box model together with maybe proxies could be a better way to facilitate explainability. Then guidance on accuracy versus interpretability trade-offs. We really ask ourselves and you to inform the stakeholders that this is their choice. That we will need to sacrifice accuracy for interpretability. If we want to have this 7th digit after comma improvement in accuracy on the test set, we may need to add additional variables, but at the expense of potentially modeling unnecessary effects. And the last one would be good is the storytelling part. Now everybody's building stories, and I think a story supporting the results of what you did and why it is important is a very good way to improve reliability and build credibility at the end user. So this is the summary. If you want, we have prepared another story on how to do everything that I showed you, but in a Python Jupyter environment. There's also, our contact details can be shared later, but now maybe we can go either into questions or let Sean show you other stories and how can you do hardcore optimization right from Python.
I will give it 2 seconds.
I think
presentation.
Yeah, I think it would be nice to see that. Maybe even more than 2 seconds.
Yeah.
Great. Yeah, so we still have some time. I'm stopping sharing. Okay. Sean, it's yours.
Yes, give me 1 second. Okay, so we kind of built the same, we basically built 2 products as data stories. One of them, Katja already showed you, it's like an online platform, mostly for business experts. But of course, because many data scientists also want to interact with the business users and use the same models as they're using in our platform, we kind of built the same interface in Python so that it is easier to automate and to create new stories also using the notebooks. And we really try to also use the visualization tools and have interactive profilers so that it's much easier and quicker to visualize the models and so on. So it integrates well with Jupyter and in Pandas. I'll start from a data set, and in this case, what we're trying to do is optimize the flavor and the liking of ice cream. So we have a small data set, like 72 products, and then you have various features of the ice creams in this case. So what was the fat level, the sweetness, the tackiness, and so on. And we had a few KPIs, the liking texture, the liking flavor, and the liking overall. What we really try to do is, because we really love the interactivity of things. So coding, of course, is fantastic if you want to automate things. But many times you notice as a data scientist that you're staring at lists and lists of things, and you really want to visualize them quickly and interact with them. So for example, we built simple functions on compute data summary. And what you will get is a very quick overview of all the features in your data set, something to quickly see and see how complete the data is. This is a very small test set that we found on the internet. In reality, we probably would need a bit more data. But it is quick, and you can quickly see, for example, okay, there's 3 empty columns at the end that we should probably filter out. And you can quickly say, like, for example, yeah, I don't want to take the ice cream ID into account, and yeah, these unnecessary variables. And then you quickly can insert a cell and have a selector that automatically selects the features that you want. So if we then have all the features, we also have to determine what are the KPIs. It could be done in the same way as above. And like for now, when I talk about KPIs, I usually the key performance indicators. As data scientists, you would call them outputs of targets. But mostly for our business user, we use the term KPI. And in this case, we were mostly trying to optimize the flavor and the liking overall. So what we then can do is train, using data stories, quickly a machine learning model that takes both features immediately into account. Yeah, this is a very small data set, so it only took like 1.4 minutes. And what we then get is the same kind of structure. So you run the story, and you get back an object. And this object you can serialize to disk, you can load it later on. And you can get all these interactive elements out of it. For example, when you evaluate the story, you just see the basics, like the driver's overview, as Katja already showed you before. But here you can, for example, see that the liking flavor and the liking overall has some different drivers. So both of them are determined by how milky the dairy is in there and the melting rate. But for example, the liking of flavor seems to be mostly influenced by the level of fat that's also in there, while the liking overall has no influence from that whatsoever. And there's a few other drivers that we can see that have an influence in one of the KPIs and not in the others. Of course, if you now see that there are some influences that you didn't want in there, some variables that you want to remove, then you can go back and remove them from the selector. There's various other things I will quickly go over them, like you can quickly explore the correlation in between your features. It's now less of an important, and you can go into the same like of interactive profilers in a very easy story.whatifs. So what you can see here is immediately you can have these profilers, you can already find some optima, or you can automatically like minimize and maximize all of them or a certain set of them. And if you really like it, you can say, okay, no, I want to send this to a user. You can export it as an HTML, and then people can just interactively use it. But of course, what we really wanted is to also optimize those KPIs. For example, we want to maximize the flavor, we want to maximize the liking. And for example, if we want to make a dietary product, so like we want to minimize the fat levels. And these, of course, are, as we have seen, are conflicting conditions, but it is still something that you can try and do. And then, of course, we define the spec. We run the optimizer. And of course, it works the same way as you saw before in the platform. And then you can immediately get a dictionary, basically what all your settings are, and with all of the KPIs involved. And if you want, you can bring them back into the same kind of profiler so that you can manually explore the result and maybe change a few things or still adapt the solution and go back to your specification. So this is a very, very, very quick overview of the things that we're doing at Data Stories and what we're trying to do. And as you saw, we mostly try to focus on the actual thing, on the explainability and the visualizations of things, and a bit less on selecting the algorithms and parameters. So I think if you're interested, please contact us, and we can show you our development kit a bit more in depth.
Excellent. Thank you very much, Katja and Sean. Very, very nice tools set and very nice talk. Someone was, I'm going to spare you the clapping this time. But I encourage everyone, people have been putting clapping emojis in the chat, so that's something. Yeah, thanks again. So someone was actually asking about the notebook, since you said that they can contact you. Maybe is there a way to access that online somewhere or look at the code? Or?
So the the packages that is based on is on the data storage package, which is a commercial package. We can of course share the notebooks, but you will need also to have the package installed to actually use them.
All right. Yeah, I don't know if you had a chance to look at the questions yourselves. Some of them were, asked.
There's quite a few.
Yeah, some of them were asked maybe a little bit early in the talk. I don't know if you have any ones that you want to particularly answer. I have selected a few. Maybe one is how does your toolkit compare with AutoML from Google in terms of model building? One question maybe.
You want to take it, Katja, or you are on mute?
Right, I'm not on mute anymore. So we, if you compare, if you do the side-by-side comparison of the quality of machine learning models, very often, and especially on Kaggle data sets, we would have a slightly lower accuracy, but a lot less variables selected. And so this is a very important point. So this is the price we pay for explainability. If I run, we would probably be the top 2%, but for us, it's not the accuracy is important. If we can, so we are now making a decision of removing the variables if it is only contributing to less than 2% of cross-validation error. So the performance on model building would be slightly lower, but we always compete with the AutoML tools to our clients, and then so far we were winning simply for the explainability part. So I think as soon as the Google, so what is now important is what you do with the model. And there I think we have an edge, at least today.
Great. Some people were wondering about how do you actually estimate the feature impact on the targets. Someone mentioned Shapley values and other methods. I think you also talked about them. Maybe you can summarize like what are the methods or what you're using.
Right, so in our machine learning algorithm, it's an iteration. We start with all variables. And again, you can just plug in like 15, 20,000 features. The purpose of the algorithm is to iteratively optimize complexity of the models together with a cross-validation error and let the features compete with each other in a spirit of fixed resource allocation. So variables compete for the right to be in the models. And iteratively, we increase the complexity of the models because complexity, accuracy control is very important for us. So increase complexity, reduce number of features. At the end, so we stop the training when we cannot eliminate any more features out of the model, but where the model has similar cross-validation error on the training and on the validation set. And then ultimately what we report as a feature, maybe Sean was showing it, so the feature importances are then rescaled, so they sum up to 100%. So these are the relative measures of importances. I saw one question, someone asked, how do we estimate the impact of unmeasured variables? Right. Yeah, so this is very hard if you don't, because machine learning is very naive. If you did not, it depends on the user. So we believe that something is important if its presence or absence matters. If we did many iterations and we did not achieve the required level of accuracy for our models for a reasonable number of records, then we conclude that either there is no relationship whatsoever or we're missing some features. And then we talk to then domain experts, sit and think of what else could they measure and add to my data set to improve the accuracy. So every real application is actually an iterative process. You start with the data, you do it in an agile way. You see the accuracy, you figure out what you might be missing to push the accuracy up, and then you add these new features that you didn't think about immediately.
I see.
Sean, there was also a question about the technology stack. Maybe you can take this one, and then Daniel should further.
So many questions.
Yeah, that was something. What's the technology stack you're using? I think we saw many things in the notebook anyway.
Yeah. Yeah, here I see. It's just there's no more details. Well, we have like parts of it of our stack is Python, lots and lots of it. And Python is our glue. Unfortunately, we started our backend of our platform before we know FastAPI, so it's a Flask-based backend with some validation for using Marshmallow and so on. When we go deeper into the algorithms, most of them are C++, and either we, of course, we also use various open source tools and so on in the backend to calculate various things. But the core of the algorithms is written in C++. And then, of course, yeah, lots of JavaScript to actually using V3 to do the visualizations. Our front end is also is using Vue, so we're not really React fans. Yeah, ask any more specific questions if you want to. It's containerized using Docker. We're mostly on AWS.
Great. Someone said they liked your plots a lot. Is there maybe a recommendation for some tools for model visualization where you can vary some of the parameters?
Data stories? No.
All right. Yeah.
No. I mean, all tools work well. It's mostly like what you put on the visualizations that matters more than anything than the exact tool. And this is, in general, I mean, even using MATLAB, you can create visualizations like this if you want to.
That makes sense. Yeah, sure.
But you want to make sure that your model evaluator is very efficient, because every time we make the plots, I move one slider, but actually we recalculate 1,000 points in every dimension out of 6. So there is a lot of function evaluations that need to happen and then be built in real time in your browser. These are very lightweight plots. So we very fast ourselves, just using pure. I think something was in C++, the bundle evaluator. Sean can comment more on this.
Yeah, we lost you, I think, for a second, but I understood we wrote and then C++. Good. Yes, so the model evaluator is in C++, and for real-time evaluation in the browser, we also use things like emscripten to actually like that. That's why the sliders are so interactive, because we don't have to go back all the way to the server and to do the evaluator.
Nice.
There was one comment I noticed, if I may, from Yefim Shuf. Thank you. So slide, I might have said that we want to replace machine learning, replace the outputs with the models. Of course, we never replace. The true outputs is the ground truth, is the only thing that we can rely on, is measurable data. What we want to do we want to augment it, because the output could be measured once in a while. It could be very expensive. You take a sample, you bring it to the lab, time understanding of the output. So we always augment and improve, never replace, indeed. Thank you for the comment.
Yeah, maybe you have another one or that you'd like to pick from the list? Last one.
Explanation. How do you define and measure an explanation? I don't define it, but again, as I mentioned, if they are not sure whether it is clear, it is not clear, right? If you have doubts. So the domain experts look at the drivers. First, they figure out whether drivers, so the input in the model, whether they make sense. Then they ask a question, how exactly are they combined together within a machine learning model? And then they spent quite a bit of time playing with the sliders there. And then so the best way to measure the explainability is to not intervene into the process and then have your customers or users tell you that they have discovered 8 to 10 new hypotheses about their processes using this simple and naive tool with sliders that they didn't think about before. So this is the only true measurable indication for explainability. But it's a good way, a good point to.
It's when they
to formalize
when
it.
they actually link the output of the machine learning models mentally with their process that they have, and can truly like verify, okay, this makes sense because when we do this, when the shift changes at that moment, and they do this and that, then this will happen. So it's when the connection is made with their mental model, usually that's the full explanation. With their mental model, usually that's the full explanation. With their mental.
When they tell you, yeah, it's obvious because look at this. And when they start showing each other the sliders, because it is an obvious thing, that means that you build something explainable.
Perfect. Well, thanks again. I enjoyed it quite a lot. Thanks for your time. I think we're at the end of the event. So thanks to all the participants. Did you have a slide for some, I guess your URL, sorry, Katja and Sean, it was datastories.com or?
Right, datastories.com.
And maybe I'll let you wrap up, Trent.
Yeah, and actually just, so thank you, Sean and Katja, very much for your talk. Really informative and really fun and great to see the progress. And just for the audience's sake too, maybe Sebastián, would you like to share maybe a URL that people should go to or some particular link that?
Yeah, where should I share it?
Just mention maybe and
yeah, fastapi.triangulo.com. Or you can actually just Google FastAPI and you will find the document. Yeah.
That's true. Google does it all. Yeah, so, Katja and Sean as well as Sebastián, thank you once again for all the wonderful, the really great talks and the great question. Thank you to the audience as well. Really great questions. I learned a lot from both talks. And with that, maybe I'll just, that's all for me, but I want to just ask Abhishek too. Anything to add, Abhishek, yourself?
No, I don't, Trent. Thank you very much to all the speakers and to all the audience. And we had a lot of people today, and I hope it continues. So, not like this. I mean, it should not continue virtually all the time. But yeah, thank you very much, and goodbye.
Yeah, thanks everyone, and we'll see you guys again in a month. To the audience or wherever, we are the first Monday of every month as usual. So yeah, see you next month.